Hello and welcome to the Control Strategy session. In this session, I will explain which aspects a control strategy needs to cover and how it can be implemented. Control strategy, what is meant? Let me explain that by showing the difference between batch and continuous manufacturing. As we have discussed in the first chapter, in traditional batch manufacturing, quality control is typically based on the testing of the outcome of a specific unit operation. The sequence would look like this. First, set a process parameter. Then run the batch in one unit operation, for example blending or tableting. Then a sample of the intermediate or final product is taken and analyzed in the laboratory while the material is in storage. If the test is okay, the entire batch is transferred to the next unit operation or released for sale in case of a final product test. If the test is not okay, the entire batch is discarded or sometimes reprocessed. When continuous manufacturing is implemented, more sophisticated control strategies can be developed, resulting in a more complex control concept. As you know, all unit operations run at the same time, are connected, PAT tools are installed, and process parameters are monitored in real time. With the gained knowledge, quality control and process control concepts can be implemented. Let's look at quality control first. Quality control is equivalent to checking the batch after production. The availability of real-time information on the materials allows for identifying out-of-specification material, which can then be discarded from the process. Therefore, only in-specification material will ultimately form the final product. Next to this quality control aspect, also process control methods can be applied to continuous processes. When talking about process control, we are talking about methods that automatically adjust critical process parameters, abbreviated to CPPs, in real time to keep the critical quality attributes, abbreviated to CQAs, close to their desired reference values, which we check with PAT tools. That means that the effect of raw material variations that would deteriorate the final product quality can be attenuated. In case of severe disturbances, quality control will step in and out-of-spec material will be discarded. Process control is also needed in continuous processes to keep the hold-up in the respective unit operations at the desired levels. So quality control is responsible for discarding out-of-spec material from the process, and process control is responsible for ensuring the material stays in spec at all times. For both, we need to know certain things to create process models that allow us to control the process. Let's discuss this in detail now. For quality control, we need to track the material. The measurement and discharge locations are often at different positions in the manufacturing line, and one needs to be able to monitor the propagation of the material through the manufacturing line to know when out-of-spec material approaches the discharge point. Further, many pharmaceutical unit operations are capable of attenuating disturbances. For example, API concentration fluctuations will be reduced when the material passes the tablet press feed frame. The residence time distribution models we have discussed are used to perform material tracking and predict the attenuation of disturbances. For process control, the system's behavior needs to be known. By that I mean that one needs to understand how the system output, like the material attributes, mass flow rate, etc., reacts if process parameters change. The behavior of the system is mathematically described utilizing a process model. So-called model-based control approaches are implemented. For that purpose, mathematical models of the investigated unit operations are needed. So both quality control and process control rely on suitable process models. This means that for quality and process control, so-called model-based control approaches are implemented. With that, I thank you for your attention and see you soon for details on quality control.